For this video, I want to go over the logic for our pushAtIndex function. Below is the function definition, and on the right hand side, I have our main function. In our main function, I went ahead and called our pushTail and pushHead function to create a linked list. On our linked list, I have it in increments of 10, and this is what it looks like in the heap. I have 10, 20, 30, and 40. And what I want to do is I want to insert, and let's make this a 5, this node into index 3. I went ahead and created an activation record for main. Inside of our main, I have a head pointer that is pointing to null. Below this line, I have called our functions to create our linked list. Once we call our pushAtIndex function, we insert the address or our head pointer, and in this case, it's going to be 0x50. So this becomes a 0x50. We want to push it at index 3 right here. This 3 will be shifted to the right and will become index 4. And we want to add the value 5. So let's trace the code. When we call our pushAtIndex function, an activation record is created on the stack. And inside the function, we have a double pointer head that holds the address of 0x50. And that head is also currently pointing to our first node in the heap. When we get to line 221 to 228, a new node is created. So in this case, we are going to enter 5 into our node, and this currently will be set to null. So on line 221, a new node pointer will be created, and that new node pointer will be pointing to this new node that is created in the heap, and it's going to hold the address of 0x500. We then go to line 230, and we have a current node that is created, and we set head to that current node is pointing to the first node. We then create an index I that mirrors our index numbers here in blue. And then we also have a num nodes, and we assign the number of nodes because count nodes returns an integer. So in this case, it's going to return 4 to num nodes. We then go to lines 234. We've already done this in our prior videos. If head is null, and in this case it is null, then we're just going to set our new node, which is represented in this picture here. We're just going to set that to the address of head, so head will just point to that. And if you want to see more of that, just watch the push head and push tail videos. And again, we go to lines 241. If we want to insert it at index 0, then all we simply do is call the push head function. And you can watch that push head video if you want to understand the logic to it. But here I'm just going to explain it briefly. On the green side at the bottom, if we have a linked list and current is pointing to the head node, and we want to insert this new node into index 0, so index 0 will be right here. All we want to do is assign new nodes next, which is this, to equal head. So we want to do new nodes next to equal, or assign head to it. So this will point to that. And after that, we want to assign head to new node and also current to new node. So this is what the algorithm in a short explanation will look like. We then go to lines 246, and 246 is just an error check. So basically what this says is that if an index that is out of bounds is requested, so for example, if it's -1 or more than the number of nodes that we have, in this case, if you're asking to insert it at index 5, then this will be printed. Index out of bounds must be between 0 and 4 or 0 and 3, however many nodes that we have. We then go to line 254, and this is what I really want to concentrate on because that's what we're going to do here. This is the heart of our code. So what we have here is on line 256, while I does not equal index -1. And the reason why we have index -1 is because I starts at 0, whereas index starts out at 1. And so we want to make sure that these two are equivalent in terms of their numbers. And in this case, our index that we want to insert is 3. So I starts out at 0. Index -1, and in this case, index is at 3. So 3 minus 1 is 2. So we check the condition. I does not equal 2. That is a true statement, and so we go to line 258 and we traverse current to the next node, and then we increment I, so I becomes 1 with our I++. We go back to line 256. I is not equal to index minus 1. I is not equal to 2. That is a true statement. So we stay inside the while loop. We go to line 258 and we traverse current to our next node. We increment I with I++, so I becomes 2. We then go back to line 256 and we check the condition. I does not equal to index. 2 does not equal to 2. This condition becomes false, and so we exit out of this while loop. And when we exit out of this while loop, we assign currents next to new nodes next. But notice how our current stops traversing before we reach the index that we want to insert our new node in. And so when we assign currents next to new nodes next, our new node next will then be pointing to our currents next. Well, where is our currents next pointing to? Currents next is pointing to 0x400. So this will become 0x400, and this will point to here. And on line 262, we're going to assign currents next, which is right here, to new node. So this becomes 0x500, and this points to our new node. And notice how our links are all connected. Now, in this case, order matters, because if you have 262 before 261, then one of our links will break and we will have a memory leak because one of the nodes won't be connected and we won't have access to that node. So notice how 0 is linked to 1, 1 is linked to 2, and 2 is now linked to our new node, which will become index 3, and this will become index 4. Okay, let's run and compile this code. And there it is. Notice how our push at index 3, the new node, was inserted at index 3. And also notice how index 4 used to be index 3 and is now shifted over to index 4. As far as time complexity, our best case scenario here will be O of 1 constant if we are inserting at the head node. But otherwise, it's going to be O of n because we have to traverse until we reach where we want to insert our new node. And that's our pushAtIndex function explained. Thank you.